Hi students, okay, today we are learning the topic is triple integrals. So in the previous lectures we completed double integrals, okay na? So now we are finding the three-time integration of three variable function, okay na? See the first of all definition. So let f of x comma y comma z be a function defined over three-dimensional finite region W. Then the triple integral of f of x comma y comma z over the region W is denoted by triple integration over W f of x comma y comma z into dw, or integration over W f of x comma y comma z dx dy dz. So this is called triple integral and three-time integration of three variable function. Okay, here first integrating with respect to x, y or z, any variable. So x, y, z limits are constants, may be functions, and first integrating, for example, assumption with respect to z. So z limits are constants or functions of x, y. So second integrating, for example, with respect to y limits are constants or function of x. So third integrating with respect to x limits are must be constants. So the last integrating with respect to any variable, that variable having the limits are constants. So this is the evaluation of triple integral. Okay, now see the example here. Okay, see the first example. Evaluate integration 0 to 1, integration 0 to 1, integration 0 to 1, x, y, z, dx, dy, dz. So this is the simple form, and this is also short question, very important question. This model, maximum 90% the question will be given in the examination. Okay, na? This is short question. So there is equal to here integration assumption here with respect to dx, dy, dz, and x limits, y limits, z limits all are constants. So an assumption, this is x limits 0 to 1, y limit 0 to 1, z limit 0 to 1. Okay na? So function is also x, y, z. X, y, z means the also function separating. So integrating is also separating. So that is equal to integrating z into dz, integrating y into dy, into integration x into dx. Okay na? So separating, integrating here. So integration of z square by 2, z limit 0 to 1, integration of y square by 2, y limit 0 to 1, integration of x square by 2, x limit 0 to 1. Substituting here upper limit, lower limits, 1 by 2 minus 0, 1 by 2 minus 0, 1 by 2 minus 0, that is equal to here 1 by 8. So this is a required result of the given triple integral. Okay, see the next example. So evaluate integration x is equal 0 to 1, integration y is equal 0 to 1, integration z is equal to square root of x square plus y square to 2. So observing here, first integrating with respect to z, because z limits are functions of x, y. Second integrating with respect to y, third integrating with respect to x. So that is equal to here. So function is x, y, z. First with respect to z here, and x, y is a constant, x, y into integration of z square by 2, z limits, z is equal to square root of x square plus y square to 2 into dy dx. That is equal to integration x is equal 0 to 1, y is equal 0 to 1, x, y into, substituting here 4 by 2 minus lower limit, squaring the root cancel, x square plus y square by 2. Okay, now with respect to y, multiply with y. So that is equal to 1 by 2 is a common, 1 by 2 into integration x is equal 0 to 1, integration y is equal 0 to 1, x into multiply with y, 4y minus x square y minus y cube into dy dx. Now with respect to y, integrating. So 1 by 2 into integration x is equal 0 to 1, x into integration of y square by 2 minus x square into y square by 2 minus y power 4 by 4. Substituting y limits, upper limit 1, lower limit 0. So substitution. So that is equal to, after substitution, 1 by 2 into integration x is equal 0 to 1, x into 4 by 2 minus x square by 2 minus 1 by 4. Lower limit 0, minus 0 plus 0 plus 0 into dx. So that is equal to here 1 by 4 common here, 1 by 8. The constant 1 by 8 outside the integration. Integration x is equal 0 to 1, 8x. So 8x minus 2x cube minus x into dx. Now integrating with respect to x. 1 by 8 into 7 into x square by 2. 8x minus x, 7x. 7 into integration of x square by 2 minus. So 2 into x power 4 by 4. And 2 cancel, x power 4 by 2. Substituting x is equal 0 to 1, upper limit 1. 1 by 16 into 7 minus 1. Lower limit 0. So that is equal, simplification is 3 by 8. So this is the required result of given integration. Okay, is it clear? Next example. So evaluate integration 0 to log 2, integration 0 to x, integration 0 to x plus y, e power x plus y plus z into dz dy dx. So we observe that here first integrating the limits are function of xy and the z limits. First integrating with respect to z. The z limit 0 to x plus y. Next function of y 0 to x and the y limits. So next third integration with respect to x. X limit 0 to log 2. So that is equal to first to integrating with respect to z. So e power x plus y plus z separating here. So that is equal to here e power x into e power y into e power z. So with respect to z, e power x, e power y is a constant. Integration 0 to log 2, integration y is equal 0 to x, e power x into e power y, integration of e power z and e power z. Substituting z limits 0 to x plus y. That is equal to integration 0 to log 2, integration 0 to x, e power x into e power y. So that is equal to e power x plus y minus 1. So now multiply with e power x into e power y. That is equal to integration 0 to log 2, integration 0 to x. So e power 2x into e power 2y minus e power x into e power y into dy dx. So now integrating with respect to y. That is equal to integration 0 to log 2. So e power 2x into integration of e power 2y and e power 2y by 2 minus e power x into integration of e power y and e power y. Substituting y limit 0 to x. So that is equal to here so integration 0 to log 2 e power 4x by 2 minus e power 2x minus e power 2x by 2 plus e power x. So now simplification after integrating e power 4x by 2 and the integration of e power 4x, e power 4x by 4 and 8 minus. So this is 3 by 2 kada. E power 2x minus e power 2x by 2 and 3 by 2 e power 2x. So 3 by 2 into integration of e power 2x and e power 2x by 2 plus integration of e power x, e power x. So substituting 0 to log 2. Upper limit x is equal log 2. That is e power 4 log 2 by 8 minus 3 by 4 into e power 2 log 2 plus e power log 2 minus 1 by 8 plus 3 by 4 minus 1. That is equal to 2 power 4 by 8 minus 3 by 4 into 2 square plus 2 minus 1 by 8 plus 3 by 4 minus 1. After simplification this, take the LCM and simplification is 5 by 8. So this is a required value of given integral. Okay. So next example, evaluate integration 0 to 1, integration 0 to 2, integration 0 to e dy dx dz. So first with respect to y limits 0 to e, x limit 0 to 2, z limits 0 to 1, because the integrating order is given and x y z limits are all are constants kada. So first of all integrating with respect to any variable x, y or z. So but given order, first y, next is x, next z. So that is equal assumption. So y limits 0 to 1, x limit 0 to 2, z limit 0 to e. So assumption anyway, and not only x limit 0 to e or y limit 0 to e, choosing any one, because result is no change, because all are constants, and integrating is also with respect to dy dx dz function is 1. So that is equal to integration is integration of 1 y limit 0 to 1, integration of 1 x 0 to 2, integration of 1 z 0 to e. That is equal, substituting the limits 1 minus 0, 2 minus 0, e minus 0, that is equal to 2e. So this is the required result of the given integration. Okay. So మనకి limits are all limits are constant అని అనుకోండి. Now integrating with respect to any variable x, y, z first of all. Okay na? So next example. So integrate f of x comma y comma z is equal to 1 minus z square over the region W is the tetrahedron with vertices 0 comma 0 comma 0, 1 comma 0 comma 0, 0 comma 2 comma 0 and 0 comma 0 comma 3. So here there is no given directly limits and okay, region is the given, the region is the tetrahedron. So tetrahedron is intersect the x axis, y axis, z axis at the points given. Okay na? So first of all finding the limits and then finding the integration. So that is equal to given function 1 minus z square. So clear limits x is equal 0 to 1. So 1 comma 0 comma 0 intersect at x axis, 0 comma 2 comma 0 intersect at y axis, 0 comma 0 comma 3 intersect at z axis. So x limit 0 to 1 is a clear, y limits are 0 to 2, z limit 0 to 3. So that is equal to integration x is equal 0 to 1, y is equal 0 to 2, z is equal 0 to 3, function 1 minus z square into dz dy dx. That is equal, first integrating with respect to z. So that is equal to integration of 1 z minus integration of z square z cube by 3, z limit 0 to 3 into dy dx. Substituting z limits integration 0 to 1, integration 0 to 2. So 3 minus 9 minus 0 plus 0, that is equal to here minus 6, integration 0 to 1. Now with respect to y, so integration of 1 ante y limit 0 to 2, minus 6 into integration 0 to 1, 2 minus 0 into dx. So that is equal to 2 into minus 6 minus 12. So that is equal to here integration of 1 x limit 0 to 1, that is equal to value is minus 12. So this is the required value of the given integration. So there is a tetrahedron and so intersecting at x axis 1 comma 0 0, at y axis 0 2 0, at z axis 0 0 3. There is a tetrahedron. Okay na? So this is a given integral value. See the next example. So integrate f of x comma y comma z is equal to 2x minus y plus z over w is the region bounded by the cylinder, z is equal to y square, the xy plane and the planes x is equal to 0, comma x is equal to 1, comma y is equal to minus 2, comma y is equal to 2. So clearly the given region is bounded by the cylinder, z is equal to y square, and xy plane means z is equal to 0 kada. So that clearly z limits 0 to y square. So that is equal to x limits the clear 0 to 1, y limits minus 2 to 2. So therefore the given integration, so x limit 0 to 1, y limit minus 2 to z limit 0 to y square. Given function 2x minus y plus z, that is equal to integration 0 to 1, integration y is equal to minus 2 to. So integration of 2x minus y plus z with respect to z first of all, ante 2xz minus yz plus z square by 2, z limit 0 to y square. Substituting first upper limit y square. So integration 0 to 1, integration y is equal to minus 2 to 2. So 2x y square minus y cube plus y power 4 by 2 minus 0 plus 0 minus 0 into dy dx. So now with respect to y, integrating with respect to y, so integration x is equal to 0 to 1, 2x into y cube by 3 minus y power 4 by 4 plus y power 5 by 10, y limits minus 2 to 2. So substituting upper limit and lower limits of y, that is equal to simplification is, so integration 0 to 1, 16x by 3 minus 4 plus 16 by 5 plus 16x by 3 plus 4 plus 16 by 5 into dx. Now simplification that one and integrating with respect to x. So first simplification, integration x is equal to 0 to 1, 32x by 3 plus 32 by 5. Now integrating with respect to x, 16 and x square by 2 kada. Integration of x square by 2, 32 by 2 and 16, 16 x square by 3 plus 32 by 5 into x. Upper limit 1, lower limit 0. Substituting 16 by 3 plus 32 by 5 minus 0 minus 0, that is equal to simplification 80 plus 96 by 15, 176 by 15. So this is the required value of the given integration of the given function. Okay. See the next example. So find the volume bounded by the planes x is equal to 0, y is equal to 0, comma z is equal to 0 and x plus y plus z is equal to 1. So value means triple integration over the region, and a function is only 1, that is equal to value means integration of dx dy dz over the given region. So your given region is bounded by x is equal to 0, y is equal to 0 and z is equal to 0 and x plus y plus z is equal to 1, and a tetrahedron. Now finding the volume of the tetrahedron. So there is a given region is x is equal to 0, y is equal to 0, z is equal to 0 and x plus y plus z is equal to 1. So assumption that the limits is, for example, z is equal to 0, then from the plane z is equal to 1 minus x minus y. So z is eliminating, next remaining x y kada, and y is equal to 0, then y is equal to x right outside 1 minus x, that is a y limit 0 to 1 minus x. So now y eliminate, next to remaining x, and x is equal to 1 and x is equal to 0 to 1. So there is a limit, and z is equal to function of xy and y is a function of x and x is a constants. So similarly we can same with taking. So x is a function of yz, no problem, or y is a function of zx, you can choosing any way. So that is equal, now we choosing that one. Okay now, so there is a limits. Now finding the integration is, there is a volume is equal to integration of dx dy dz, that is equal to integration x is equal 0 to 1, integration y is equal 0 to 1 minus x, z is equal 0 to 1 minus x minus y. First integrating with respect to z. So integration x is equal 0 to 1, y is equal 0 to 1 minus x, integration of 1 z, z limit 0 to 1 minus x minus y dy dx, that is equal to integration 0 to 1, integration 0 to 1 minus x, substituting z is upper limit, lower limit, 1 minus x minus y minus 0 into dy dx. So now simplification, next integrating with respect to y. Okay, so that is equal to integration x is equal 0 to 1. So integrating with respect to y kada, y minus x minus y minus y square by 2. So y limit 0 to 1 minus x, substituting here, upper limit 1 minus x. So integration 0 to 1, 1 minus x into 1 minus x minus 1 minus x whole square by 2 minus 0 plus 0 plus 0. Now simplification, that one, integration x is equal 0 to 1, here 1 minus x common, 1 minus x into 1 minus x. So from this one here, from this one 1 minus x common, remaining 1 minus x minus 1 minus x whole square by 2. So that is equal to 1 minus x whole square minus 1 minus x whole square by 2, that is 1 by 2. 1 by 2 into 1 minus x whole square. Now integrating with respect to x. So 1 minus x whole square integration 1 minus x whole cube by minus 3. Minus 3 into 2 minus 6. Substituting upper limit 1 and take 0. Next to plus 1 by 6. So that is equal to 1 by 6. This is the given result. Okay. See the next example. Evaluate integration over w dx dy dz, where w is the finite region of space formed by the planes x is equal 0, y is equal 0, z is equal 0, and 2x plus 3y plus 4z is equal to 12. So that means indirectly we have to finding the volume of the given region. The region is bounded by the three planes. X is equal 0 means yz plane, y is equal 0 means zx plane, z is equal 0 means xy plane, and including other plane 2x plus 3y plus 4z is equal to 12. First of all, now finding the limits in the region. So that is equal to given. Similarly, same procedure the previous problem. So assumption z is equal 0. First of all, z is equal 0 from the plane. Z is equal, we write 4z is equal 12 minus 2x minus 3y. That is equal to z is equal to 1 by 4 into 12 minus 2x minus 3y. This is the z limits. And the first z eliminating, remaining xy. And the 2x plus 3y is equal to 12. Next assumption, y is equal 0. Y is equal 0. 3y is equal to 12 minus 2x. That is equal to y is equal to 1 by 3 into 12 minus 2x. So similarly automatically x limits are constant here. Y eliminating, z eliminating, remaining 2x is equal to 12, and x is equal 0 to 2x is equal to 12, and x is equal to 6. So x limit 0 to 6. This is the given limits in the given region. Now finding the integration using these limits. So integration over w dx dy dz is equal to integration x is equal 0 to 6, integration y is equal 0 to 1 by 3 12 minus 2x, integration z is equal 0 to 1 by 4 into 12 minus 2x minus 3y. First integrating with respect to z. So that is equal to integration x is equal 0 to 6, integration y is equal to 0 to 1 by 3 12 minus 12x, sorry 12 minus 2x, z is the upper limit, lower limit substituting here, integrating of 1 z kada. So that is equal to integration x is equal to 0 to 6, integration y is equal to 0 to 1 by 3 12 minus 2x, upper limit 1 by 4 into 12 minus 2x minus 3y minus 0. Okay, now with respect to y, integration 1 by 4 common, 1 by 4 into integration x is equal to 0 to 6 with respect to y kada, 12y minus 2xy minus 3 into y square by 2, y limit 0 to 1 by 3 12 minus 2x, substituting upper limit and lower limit. So 1 by 4 into integration x is equal to 0 to 6, 12 into 12 minus 2x by 3 minus 2x into 12 minus 2x by 3, that is equal to here 3 by 2 into 9, 12 minus 2x whole square into dx. So after simplification, now here first of all simplification, after that integrate with respect to x, that is equal to 1 by 4 into integration x is equal to 0 to 6, 12 minus 2x is the common, so remaining 12 minus 2x minus 6 minus x by 3, that is equal to 1 by 12, integration x is equal to 0 to 6, so that is equal to here 2 common here, 6 minus x into 6 minus x, simplification ikkada 2 common here, 12 minus 6 6, 2x minus plus x minus x, so that is equal to 1 by 6 into integration x is equal to 0 to 6, 6 minus x whole square or x minus 6 whole square, both are same, so that is equal to 1 by 6 into x minus 6 whole cube by 3, so x limit 0 to 6, that is equal to substituting upper limit 1 by 6, that is 0 minus x is equal to 0 minus 6 whole cube kada, ante minus 6 cube by 3, that is equal to here after simplification is 12. Okay, so that is the result is 12 of the given integration of the in the given region. Okay, so this is so this topic is triple integration and some example on triple integration. So for more videos please do subscribe my channel, like and share it. Thank you.